I'm recording now.
Okay.
Your name's not going to show up anywhere on here, but I'm also going to put this video as it's unlisted, so you're going to be the only one who can see it, anyways.
Okay, thank you.
Okay. Left. Let's go here to left. Okay. All right. So I'm going to go quickly. I think we can stick with. I think we can stick with. I think I can do this fast enough to. All right. So we've got sodium hydroxide, which I recognize because I'm 55 years old, as
Base.
a strong base, right? I recognize that as strong base. And then I got a leading hydrogen here, and I recognize that from my nomenclature section as acetic acid. There's acetate, and there's my H plus on front. So this is going to give me potassium acetate plus
HOH.
HOH. Okay. So I'm going to come over here, and I'm going to say CVN, concentration volume, where this is my initial, and then we'll do our change and everything below that. Here's my ice table, C and E. Hope my writing is big enough to see. All right, so let's go with our red here. 0.25 moles of that. And I'm not even thinking yet. This is like a habit of mine. CV and N, 0.25 moles, and then I got 1 liter of 1.3 molar. It's 1 liter right here of 1.3 molar, and this times that gives me the number of moles. Okay, this was a little more elegant than the last one we did. So I've got a strong base and a weak acid, and since it's strong base, they get their way. Strong base. So everybody gets some action if there's enough. And there is enough. 1.3 is more. So this is going to go to 0, and this is going to go to 1.3 minus 0.25, which is 1.05. And this then is going to be plus 0.25. And that's also going to be plus 0.25, but we're told in the instructions we can ignore water. So this is going to be 0.25. So it looks like I've got, here's my weak acid and my weak base. Yeah, so I've got an acid. Oh, up here, I've got an acid. Left, and it's H3. Oops, not that. HCH3CO2. I've got a base, which is KCH. And if I get this wrong, it's going to be a formalism, all right? CO2.
So why is KCH3CO3 a base? That's kind of where I get really tripped up at.
Yeah.
Like differentiating a base.
That's supposed to be 2. It's because we had up here in this conversation earlier, we had, if you have something on here and it's got an H plus on it, it's an acid. But as soon as the H plus leaves, it's a base. So here's an acid, but when we get rid of the H plus, what it leaves behind is a base.
Oh, I got you.
Okay. So what we had here was we had acetic acid, where my H plus is right there. But when the H plus leaves,
it's a base.
It leaves exactly. Okay. So going kind of fast here. If this doesn't work out,
it's okay.
Okay. 1.05. So
I understand it.
Okay, good. So it looks like I don't think there's anything else here. If I get this wrong, it's going to be this other, because I sometimes forget these other salts or whatever. All right, so let's keep going. Let's do another version of this. I'm going to keep these same columns here, but it's a different scenario. C, V, and this is for the bottom one. Now I'm doing the bottom one. C and C where this is my initial change in equilibrium. I know that's ugly, but let's keep. All right, 0.2 molar or 0.2 moles of sodium hydroxide. Oh, this isn't the same thing. It's sodium hydroxide now. Still a strong base. Plus the same thing. Gives sodium acetate. Plus the water. Okay? So, 0.2 molar. Or 0.2 moles, sorry. Is added to 1 liter. 1 liter of this stuff over here of 0.5 molar in both. Gotcha. So it looks like there's 0.5 moles of both of these guys and 0.2 moles. All right, so since this is a strong base, it's going to all react if it can, and it can, right? Because there's enough of that. Right? You get what's going on here?
Yeah.
If I'm consuming it over here, it's got to be showing up over here.
Mm-hmm.
Okay, well, this looks, wow, pretty similar. I don't really like that, but that's the way it goes. Wow, I don't like that. Got a bad feeling about this, Nick.
Would you say this is like the hardest question on All Alex?
No.
I feel like this is the hardest one on All Alex.
No, it's because you're not used to it yet.
Yeah.
You know, you'll it is a booger. I won't deny that.
Yeah, I got to do more practice for sure before I take test 3 on this one.
Yep, it's a booger. It's a booger. All right, well, I'm going to have you already taken test 2?
Yes, sir.
Okay, I haven't even looked for that. You like your score, or you want to take it again?
Good. I like my score, yes, sir.
Okay. All right, so I'm going to check this here. I'm a little nervous. Just want to check it and make sure. But yeah, all these are gone. We've got that. I think, I don't know. If this is a mistake in here, then it's going to be something subtle. I'm going to go look at the explanation, okay?
Uh-huh. They counted it correct, though, right?
No, I don't think so.
A plus, where does that come
All
from?
right, I'll tell you why. All right. So the reason why is because this is the case, and I was saying that your base was KCH3CO2. I don't know if you remember my answer. Do I have it up here?
It doesn't say it.
It doesn't say it. Okay, but do you remember me saying that was my base up here?
Yes.
I was saying that's my base, okay? But it turns out that this stuff is aqueous. I'm still going to put this video up if you ask, okay? Or else I can make another one. I don't care. This is aqueous.
Okay.
And what this means is this really is the same thing as... Remember we did net ionic equations in chem?
Oh, yeah. I get that.
There's no molecule that looks like this. This is not a molecule. So if you have, since it's aqueous, you write those as separate things.
Oh, I get you. And then just like the minus one will be the base, and then the positive one will be the other.
This is nothing, exactly. Potassium is just nothing. You could put lots of potassium in water, and it would have no effect on the pH whatsoever.
Okay, and same with the salt.
That's right.
Okay.
That's right.
Okay, I actually get that.
Okay.
It just splits them up.
That's right. So I'm gonna post this video for now.
Okay.
And I'm gonna post the video.
Thank you. I'll definitely look over this.
Yeah, but don't look over it too long. It's you know, for one thing, you're way ahead, which is fantastic. But you're doing the right thing. You should keep pushing, and I'll do more of it with you if you like. Just don't, yeah, whatever. Don't stress yourself on it.
Awesome. Sounds good.